Now we're going to talk about beta elimination reactions. During nucleophilic substitution reactions, if you're going to attack a nucleophile on this, so the attacking nucleophile attacks the electrophilic carbon of alkyl halide. Since this is halogen, so this will be electronegative and this will be electropositive. So the coming nucleophile will attack this electropositive carbon, and the carbon and there is another site present in alkyl halide molecule where the nucleophile can attack at the same time. Since the site is an electrophilic hydrogen, this one attached to the beta carbon, since this carbon has been attached with halogen, so this carbon will be alpha carbon and this next carbon will be beta carbon. When the attack takes place on hydrogen and we get an alkene instead of substitution product, such type of reactions are called beta elimination reaction. So there is sometimes this thing is happening that this nucleophile is going to attack on this carbon, and instead of just removing this, it will attack on this carbon and removes this as well. This electron pair is going to shift on this, and this hydrogen is going to remove, and this nucleophile is going to make bond with this hydrogen, and since after that we will get an alkene molecule, and this hydrogen and this bromine is going to give us HBr. Like nucleophilic substitution can also follow E1 or E2 mechanisms. Now we're going to talk about types of beta elimination reactions. So we have two types of beta elimination reactions, E1 and E2. In E1 mechanism, the nucleophile attacks the leaving group, and leaving group leaves at the same time with the formation of carbon-carbon double bond, as we talked earlier. So we have here carbon, carbon, and all these bonds are of hydrogen. This is a base with electron pair, and it is going to attack on this hydrogen atom, and this bond is going to move between the carbon atoms. So this bromine would leave its place, and all this situation is going to happen at the same time in single step. So this will give us a product ethene. Along with that, we will get BH. Like in SN2 reactions, E2 reactions are also 2, and these reactions shows second order kinetics, and the molecularity of this carbon is 2 because 2 molecules are reacting in the first rate determining step, and is happening in single step, and also the reaction kinetics is a second order reaction. So Now we're going to talk about E1 reaction. In E1 mechanism, like SN1 mechanism, the first step is slow ionization of substrate to give carbocation. Let's talk about this. In first step, this is going to ionize and will form a carbocation here, just like that. And after this step, this will be the slow and rate determining step, and it is the first step. After this, molecule will give us a carbocation. Since this is a carbocation, we have OH negative, and this will attack on this carbon atom, giving us a product. Ethene. So the end product is both same here, but there is this little difference between these two. Since this is a bimolecular, E2 mechanism is bimolecular, and the rate of those reaction which follows the mechanism depends upon the concentrations of alkyl halide as well as the base. E1 mechanism, on the other hand, is a unimolecular mechanism. Attacking the rate of reaction depends upon the alkyl halide only, and this is the rate determining reaction.